This video is going to be a quick review of significant figures. The first thing that you need to be able to do is determine how many significant figures are in a number. So for example, let's say if we have the number 846. How many significant figures are there? Every non-zero number is a significant figure. So there's 3 significant figures in this number. Another example, 3546, has 4 significant figures. Now let's say if we have a 0 in between 2 non-zero numbers. Is that 0 significant? All zeros between 2 non-zero numbers will be significant. So 704 has 3 significant figures. 5006 has 4 significant figures. Now what about zeros to the right of a non-zero number, like 500? How many significant figures are there in this number? It all depends on if there's a decimal point or not. If we do not have a decimal point, the zeros to the right, which are called trailing zeros, are not significant. So this would be only one significant figure. In this case, the trailing zeros are significant, so this would be 3 significant figures. Likewise, if we had 500.0, this would be 4 significant figures. Now what about the zeros to the left of a number, like this 0.075? Are these zeros, the leading zeros, are they significant? Leading zeros are never significant, so there's only 2 significant figures, the 7 and the 5. So let's say if we had 0.00836, only these 3 numbers will be significant. So to review, let's try this example. 0.0050830. How many significant figures are in this number? So looking at the leading zeros, remember the leading zeros are not significant. The zeros that are in between 2 non-zero numbers, those are significant. And the trailing zeros are only significant if there is a decimal point, which we do have. So therefore, these 5 digits are significant. So we're going to have 5 significant figures. So what I'm going to do at this point is give you a quiz. And I want you to determine how many significant figures are in the following numbers. So the first one is going to be 4250, and the second one is 7080, and then 30,050 with a decimal point, and then 0.00703. Next we have 0.08060, and then 5030.0, and finally 750.064080. Go ahead and determine the number of significant figures in each of those numbers. By the way, for those of you who want harder examples, or maybe just more examples, I have another video on YouTube that is about an hour and a half long, but it really goes deep into this topic. So for those of you who want to master the concept of SigFigs, you can check out that video. I'm going to post the link in the description section of this video, so feel free to take a look at that when you get a chance. Also, if you're going to subscribe to this channel, make sure to click the notification bell if you want to receive any updates of any new videos that I'm going to post in the future. So let's go ahead and begin. So 4250, how many significant figures does it have? So the 0 at the right, do we count it? Well, it's a trailing 0 and there is no decimal point, so we're not going to count it. So therefore, we can only count these 3 non-zero numbers. So we have 3 significant figures in the first example. Now what about the second example? How many significant figures are there? Well, once again, we don't have a decimal point, so we cannot count that 0. But what about the zeros in between non-zero numbers? So those zeros we can count. So therefore this problem also have 3 significant figures. Now for the next one, there is a decimal point. So the trailing 0 is counted, and all of the zeros in between the 3 and 5 are also counted. So this example is going to have 5 significant figures. For the next one, we do have a decimal point, but there are no trailing zeros. We do have some leading zeros, but those will not be counted. So only these 3 digits will be counted. So there's 3 significant figures in that number. For the next one, we do have a trailing 0, which will be counted. The leading zeros will not be counted. So there's only 4 significant figures. Now, in the next number, 5030, we have a decimal point, so all of the trailing zeros will be counted, and the 0 between the 3 and 5, that's always counted. So we have a total of 5 significant figures. For the last example, all of the zeros in between the non-zero numbers are counted, and since we have a decimal point, the 0 to the right is also counted. So everything is counted in this example. So there's, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 significant figures for that problem. Now the next thing that you need to be able to do is you need to be able to round a number when multiplying or dividing. So for instance, let's say if we're multiplying 4.6 by 3.52. How can we round our answer with the appropriate number of significant figures? Well, the first thing we need to do is perform the calculation. So 4.6 times 3.52, if you type that into your scientific device, your calculator will give you 16.192. Now, how should we round this answer to the appropriate number of significant figures? What would you say? What we need to do first is we need to determine the least number of significant figures in the first 2 numbers that we've multiplied already. So in the first number, 4.6, there's 2 significant figures. In the second number, 3.52, there's 3 significant figures. So when you're multiplying or dividing, you need to round your final answer to the least number of significant figures in the original numbers that you used to multiply to get your final answer. So basically, we need to round this answer to 2 SigFigs. So writing it from left to right, we have the first digit, which is a 1, and then the second one is a 6. Now already, this is 2 significant figures. So the last number that we need to look at is the 6. Should we keep it as 6, or should we round it up to 7? And so we need to look at the next number. If it's 5 or more, then we need to round the 6 to a 7. If it's 4 or less, then we're going to round down. We're going to keep the 6. And because it's 4 or less, it's 1, we're going to round down. So our answer is 16, rounded to the appropriate number of SigFigs. Now let's work on some other examples. Let's multiply 5.64 by let's choose a higher number, by 12.458. And let's divide 96.752 by 3.541. Go ahead and try those 2 examples. Round your answer to the appropriate number of significant figures. So first, let's type this in the calculator. So 5.64 times 12.458. So the calculator gives us 70.26312. Now the first number has 3 significant figures, and the second number has 5 significant figures. So we have to round our answer to the least number of significant figures. So that's 3. So how can we round 70.26312 to 3 significant figures? So we're going to need the first number, the second one, and the third one. Should we keep it a 2 or should we round it up to a 3? Looking at the next number to the right of the 2, it definitely falls in the category of 5 or more. So that tells us that we need to round up. We need to round a 2 to a 3. So the answer for this example is 70.3. And it has 3 significant figures. This answer has a total of 7 significant figures. Now let's try the next example. So let's begin by dividing 96.752 by 3.541. And so you should get 27.32335,498. Now the first number has 5 significant figures, and the second number has 4. So like always, when multiplying or dividing, you need to round your final answer to the least number of significant figures, in this case 4. So looking at the 4th digit, or the 4th significant figure, starting from the left, should we keep it at a 2 or should we round it up to a 3? So looking at the next number, it falls in the category of 4 or less. So we're going to keep the 2. So our final answer is 27.32. Now let's talk about addition and subtraction, but mostly addition. So let's say if we wish to add 2.36 plus 12.1, how can we round our answer to the appropriate number of significant figures? So if we add these two numbers, this will give us 14.46. But what should we do here? For this type of problem, it's better to write the problem like this. Now, you need to round your final answer to the least number of digits to the right of the decimal point. So what I like to do is draw a line, because for 12.1, there is no number to the right of the 1. And so we're not going to have any number to the right of this line. But now if we add the two numbers, it's going to give us 14.46. So what we're going to do is we're going to keep this significant figure, but we need to determine if it should stay a 4 or if we should round it up to a 5. Looking at this number, it's greater than 5, so we need to round this number up. So our answer is going to be 14.5. And that's how you're supposed to do it when adding or subtracting. Let's try another example. 4.328 plus 13 plus 5.45. So go ahead and try that problem. Well, first we need to add. So we have an 8, 2 plus 5 is 7, 3 plus 4 is 7, and then 4 plus 3 plus 5 is 12. Carry over the 1, and 1 plus 1 is 2. So we get 22.778. Now what should we do next? How can we round it? So what we need to do now is determine which number has the least number of digits to the right of the decimal point. And so that's the second number. So we're going to draw the line here because it has nothing on the right side of that line. So therefore, our final answer should only contain these two digits. But we're going to use the 7 to determine what we need to do to the 2. Should we keep it a 2 or round it up to a 3? Well, 7 is more than 5, so we're going to round the 2 up to a 3. So our answer is going to be 23. And that's basically it for this video. So once again, if you want more problems on significant figures, check the link in the description section of this video for the other video where it goes into more detail on this topic. Thanks again for watching.